Welcome to Anluski Lectures. Topic is Mechanical Properties of Metals, Stress and Strain, Stress Strain Curve, Fracture of Metals. Teacher Anand Mohandas. Mechanical Properties of Metals. Key mechanical properties of metals include strength, elasticity, plasticity, ductility, malleability, stiffness, hardness, creep, fatigue, resilience, weldability. These properties can be well understood with the help of a stress-strain diagram basically. Now, mechanical properties of metal. The mechanical properties of metal determine the range of usefulness of the metal and establish the service that can be expected. We can also say it in another way, like how metal will respond to external loads. So if you understand that, we can determine the range of usefulness of the metal. Now, looking at the properties, there is strength, stress and strain. So just looking at strength is defined as the ability of metal to resist the externally applied load. The internal resistance offered by a material to externally applied forces is called stress. So internal resistance is the stress offered by the material to externally applied forces. Now, so let us look at stress and strain. Now, assume a lattice structure under shear stress. So you can see the original lattice and lattice. After stress, there is a deformation of the lattice. In the first diagram, it's elastic deformation, and the second one, deformed one, is slip, which is plastic deformation. So from the diagram you can see the original lattice deformed to another lattice, which is the distorted one. And you can see the lattice after stress, initial stress, then lattice after some time after slip, which is plastic deformation. So from the diagram itself we can understand that the atoms are misplaced or moved from one place to another or just distorted. We say it's deformation, and it's elastic or plastic deformation that has occurred. Now, the stronger the material, the greater the load it can withstand. This property of material therefore determines the ability to withstand stress without failure. So let us look at more into the more kind of stress, like when you by stress by tension, compression, shear stress, bending stress, torsion stress. You can see from the diagram the dotted one is the initial lattice, the initial size of the object, and after tension you can see it is elongated, and after compression the object becomes smaller, and by shear stress, objects just move or just, and in the bending stress you can see the object bends, and torsion stress is like a screw, object became like screw. So stress is force applied per cross-sectional area. That is the definition of stress. So stress equal to force per cross-sectional area. And strain is change in length by original length. So when you apply tension or compression, the length is changed. So change in length divided by original length is strain, and stress is the force applied per cross-sectional area. Now, stress-strain diagram, the properties of the mechanical properties can be well understood with the help of a stress-strain diagram. And I've shown a stress-strain diagram, and the change in stress as strain increases. That is a diagram, and then some points are plotted. You can see the elastic region, plastic region, and Young's modulus is the slope, that is stress divided by strain. You can see in the strain and strength, the strain and stress, the point A, the proportional limit, and point C, yield strength. Point C and B is yield strength, and D at point D it is ultimate strength, and at E the fracture occurs. I mean the object breaks, and that's in the elastic region. And you can see strain hardening also in the diagram. So this is about the stress strain curve. Now we know the plastic deformation takes place only after the elastic limit of the material has been exceeded. And this property is important in forming, shaping, extruding, and many other hot-to-cold working processes. Now let us look at the fracture of metals. Fracture is the separation of a metal into two or more pieces under the section of and the action of an applied stress. So the stress can make the ductile fracture or brittle fracture. Ductile fracture materials undergoing ductile first experience plastic deformation, and that is a material resists the fracture by stretching itself. And brittle fracture materials, they don't give a warning, they break without warning. Materials that undergo brittle fracture will fracture with negligible plastic deformation. And there is another deformation, creep in material science, some called code flow, tendency of solid material to undergo slow deformation. And the term strength can be used with various metal properties, tensile strength, yield strength, shear strength. But regardless of the property being described, strength typically refers to a material's resistance to failure. Basically, we want to know the resistance to failure. Thank you for watching the video. Thank you.